Simultaneous equations. Okay, so we have to solve for these given variables. We got x's in both equations, and they have the same value. We have y's in both equations, and again, they have exactly the same value. So what this says is 2x plus 2y equals 24, and the second equation, 3x plus 2y equals 33. So let's go about solving these. This is kind of easy in a way, in that we have 2y in both. And essentially what we do with these equations is we take, I'm just numbering these equations, number 1 and number 2. So we'll take equation 2 away from number 1. So it's the first equation subtracted by the second equation. So let's go through that. So 2y, so positive 2y minus 2y. So that cancels each other out. We have 2x minus 3x, so that's minus 1x. Okay, and on this side we have 24 minus 33, so that's minus 9. Now we can't have minus x, so we have to make that a positive, so we multiply that by negative 1, and we do the same to the other side. Don't forget, this has an invisible 1 here, right? So it's negative 1 times negative 1, which is positive 1. So it'll be positive x. And on this side, negative 9 times negative 1 equals positive 9. So I now know the value of x, and to get the value of y, I'm just going to substitute into this bottom equation. You can choose either one, it makes no difference. And I substitute in the value of x, which is 9. So 9 plus 2y equals 33. So I'm going to just simplify that. So 27 plus 2y equals 33. I can solve now, so I'm going to take away the constant from both sides. So let's do that. That cancels out. I'm left with 2y on the left equals on the right. It's going to be 6. Divide by 2 to cancel out multiplying by 2. Do the same to both sides. That cancels out. I'm left with y, and 6 divided by 2 is 3. So I know that x equals 9 and y equals 3 are the values of the variables.